Hey guys, today we are going to talk about translations. We're in Unit 1, Lesson 3, and we're going to jump right in. So a translation is a vertical or a horizontal shift, okay? So actually I'm going to write horizontal first. So a horizontal shift or a vertical shift. Just a quick reminder, horizontal goes left and right, vertical goes up and down. Okay, this is what it will look like. This is the original point. This will represent the shift or the slide of the figure. Okay, let's do a little bit more vocabulary before we do an example. A vector. A vector is a quantity that has both direction and magnitude. Direction and magnitude. I think that we understand what direction is. This arrow is going one direction, so it has a starting point and an ending point. Okay. The starting point of the direction is called the initial point. So the initial point or the pre-image. The ending point is called the terminal point. Okay. And so this symbol right here represents vector. Okay. That symbol means vector V. That line above it with the arrow, that means vector. And the V underneath it is the name of the vector. Okay. Now, vector form kind of reminds me of parentheses where I have an A, comma, B. But this does not represent a specific point. It represents a specific shift, both horizontally and vertically. So you can think of it as like a sideways V to help you remember that that's vector form. Okay. So let's take vector and translation and put all of that information together in example number 1. All right, so example number 1. Name the vector and describe it using vector form. Okay, well, the name of this vector is EF because it's going to start at point E and end at point F. All right, so let's plot the initial point, which is E, which is at -3, +4. Okay. Next, I'm going to plot the terminal point, which is F, which is +1 up 9 right here. And I'm going to try to connect these. Let me use a straight edge here. Just a sheet of paper works well as a straight edge if you don't have a ruler. Okay. Oh, this pen just doesn't want to work. Let me grab a different pen. There we go. Okay. So now what we need to determine is what is the horizontal shift. Well, we can do that easily by determining how far do I go over. So 1, 2, 3, 4. I went over 4 to the right. So this will be positive. Okay. And I'm going to put +4. And then the vertical shift. So because this is the starting point, I need to start here. So I'm going to go right, and then I'm going to go up, which will also be positive. 1, 2, 3, 4, 5. So that's up 5, which is positive. So the vector form is positive 4, comma, positive 5. And notice that it is in these little V brackets, okay? Let's talk about what the coordinate form would look like. So wherever my original X, Y values are was point E, that was my pre-image, was at negative 3, 4. Negative 3, comma 4. And in order to get to the terminal point, or point F, I had to go right 4 and up 5. And so that is my coordinate form. All right. And then that got me to 1, comma 9 to point F. All righty. Let's move along and talk about how do we determine the magnitude. Okay. So actually this little image right here should remind you of something that you spent a lot of time learning about in middle school, and it was touched upon again in Math 1. This should represent a right triangle really quickly to you. And how did we find the distance of the hypotenuse of a right triangle? So one way of doing that was Pythagorean's theorem. And that's what this is right here. So if I have vector form A, comma B, then what I would use is A, in for the A value, that would have been a positive 4, and then a positive 5 in for my B value. If I am given coordinate form, then what I would do is I would use the x plus 4 and the x plus, or the y plus 5. Okay, so this would be my x1, y1. This would be my x2, y2. And that would get me the distance. Okay, so I would say, let me just look at this here. What was my original point? Negative 3, comma 4. And then if I did what I had written on the next page, which was x plus 4, oh, and comma y plus 5, then I came out with, negative 3 plus 4 got me to 1. 4 plus 5 got me to 9. And so let's see if this purple will work. This would be, this would be the x1, y1. This would be the x2, y2. Okay, so you can find the distance or the size of that line. All right, let us do an example number 2, where this time we're given the vector, and we're going to use the vector to find the image. Okay, so I have triangle ABC here, and what I need to do, so this is my pre-image. Let's go ahead and plot my pre-image. So A is at 2, comma 4. B is at 3, comma 1. C is at negative 1, comma negative 2. And this is my pre-image. Okay, so let's plot that over to up 4 over 3 up 1, and then -1, -2. And this was A, B, C. Okay, so this is my pre-image. Now here's what I'm going to do. I'm going to apply the vector, okay? So I will have 2 plus and 4 plus. Those are my original y values, or x and y values. So the x, or horizontal shift, is a +2, so I will add 2. And then my vertical shift is -3. Whoops, so I need to change this to -3. And then I'm going to simplify and see what this equals. So 2 plus 2 is 4. 4 minus 3 is 1. This is going to be A prime, which is my image. All right, let's go ahead and plot that point. So over 4, 1, 2, 3, 4, up 1, this is now my A prime. I'm going to zoom in a little bit. Okay, let's do that same thing again. With point B, I have 3 and I have 1. So I'm going to apply my vector, which is +2 to the x value, -3 to the y value. And then I am going to simplify this. And remember, it's the image, so I need to name it B prime. 3 plus 2 is 5. 1 minus 3 is -2. So I will plot the point B prime at 5, -2. So I'm going to go over to 5 and go down 1, 2. And that's point B. Now let's do point C. -1 was the x value, -2 was the y value. I'm going to apply my vector, which is +2 to the x, -3 to the y, and that will give me C prime. So -1 plus 2 is just a 1. -2 minus 3 is -5. And then let's plot this point. So I am going to go +1 and down 5. 1, 2, 3, 4, 5. And if my eyes are working right for me, make sure that I got my prime symbols here. And now I'm going to draw my image. Okay. So I had my image and I had my pre-image. And I used the vector. So the big T stands for translate. Okay. The big T stands for translate. All right. Let's talk about what is a composition of transformations. I'm going to zoom back out a little bit. I already have an example posted here, okay? I want you to take a function and translate it with a vector of 3, 5, and then translate it again with a vector of 1, 2. So this circle in the middle means I'm going to take this transformation and this transformation, and I'm going to put them together, okay? So I put the 3 and the 1 together to get 4. And then I put the 5 and the 2 together to get 7. And now I only have to do one translation. All right. So that's how you would apply that. Okay. Let's look at an example. we're going to write a translation equivalent to the composition of transformations. So I see an R here and I see an R here. So translating, remember, is sliding them around. An R tells you that you will be reflecting, okay? So let's see how this is going to work. Now, the first thing that I want us to do is to plot the original triangle, XYZ. Okay, I want us to plot the original triangle. So I'm going to go over 1, up 5, over 2, up 3, and then -5, -2. And I am going to see, I'm going to use my straight edge so that I can make it look more accurate. There we go. Okay. So what we are going to do now is we are going to have to do a composition of transformations. And we're going to do this via graphing. Okay. So the first step that they want me to do is to reflect this over line M. Well, in order for you to know what line M is, so reflect over line M, okay? Well, line M, they tell you, is equal to x equals 4. The line x equals 4. So let me find the line x equals 4. So I'm going to go on the x-axis over to 4, and I'm just going to draw a little line here. I need to reflect my entire figure over this pink line that I just drew. And I'm going to try to zoom in really big on the graph so that we can see what I'm doing. Okay? So remember that in order to reflect across the line, if this point is 2 to the left, oh, let me label these as well. This was A, this was B, and this was C, okay? I am going to reflect the point B, so go 2 to the line and then 2 to the other line. This is going to be B prime, all right? I'm going to do the same thing. I don't know why I'm calling them A, B, and C. They should be X, Y, and Z, okay? But A is going to go 1, 2, 3 to the line, and then 1, 2, 3 on the other side of it. And then point C, okay, it's going to go 9 over to the line. I hope I have enough graph. I don't think I do. 2, 3, 4, 5, 6, 7, 8, 9. So I'm estimating now because I ran out of graph. And this would be my C prime. Okay, I'm going to use my straight edge to draw straight lines here. Give me just a second. I want to make these nice and dark so that we can see them. Okay, so I have done the reflection over line M, which is x equals 4. Now what I need to do is take that new line, take the pink, and now I am going to what I'm going to do now is to do the next part, which is to reflect the pink line or triangle over the x-axis. So I did this first, and then I'm going to do this one second, okay? So starting from the pink line, I need to reflect this over the x-axis. Now, if you wanted to, you could refer to your notes on reflecting over the x-axis, okay? When you are reflecting over the x-axis, your x values will stay the same and your y values will become negative, or opposite of what they already are. And I was going to try to pull mine up really fast just to reference for you in case you forgot, okay? So reflections, let me just pull these out. So a reflection over the x-axis is right here, okay? From the original point, the x value stays the same and the y value is negative, okay? So what that means for us is, if I want to think about it this way, okay? This B point, I'm going to go down 3. And then now I'm on the x-axis. And so from there, I want to go down 3 more. That is what we call B double prime. I put 2 little tallies there. Okay, so this is the pre-image. This is the first image. This is going to be the second image. It's kind of equivalent to what you see in real life, then what you capture in your camera, and then this would be what filter you might put on top of the picture to change it, okay? A1, I'm going to go straight down 1, 2, 3, 4, 5. And from the x-axis, go down 5 more. 1, 2, 3, 4, 5. The x value stayed exactly the same, and the y value is the opposite. Okay, so instead of positive 5, it's now at negative 5. All right, and so this C, I am going to have to go up. Let's see. This is down 2. So 1, 2, and then I'm going to go up 1, 2. And again, this is sort of an estimation because I ran out of graph. Okay. And now I'm going to use my straight edge so that I can draw a nice straight line here. Okay. Oops. Actually, my straight edge was not on the A dot. It was on the A letter. There we go. Okay. Yep. This is where the A should be, is up here. So this blue image is the final answer to my composition of functions. So I had to do 2 things to this one image. All right, let me just check my notes, make sure that there's nothing else that I need to include other than just a note. Okay, I'm going to color this in, make it nice and solid for you. Okay, this is the final. This is the final image, okay, after you did over the x-axis. Whoops, I'm sorry, I forgot I was zoomed in so far. There we go. Now we can see the entire problem. Okay. All right, guys, that is everything that we are going to learn today on translations. And just notice that not only did we talk about composition of translations, we extended that into compositions of reflections as well. Reflections was our last lesson. All righty. There is a practice assignment posted for you onto Canvas. And as always, I'll see you next time.